Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over acid-base titration. So what is a titration anyway? Well, a titration is a lab technique where you are going to be taking a substance that is in a solution that you know the concentration of, and you're going to be reacting it with a substance in another solution that you don't know the concentration of. And you're going to know the volume of one, and then by titration, you're adding incrementally amounts of the known substance into the unknown, such that they will neutralize each other. And then when you reach the point at which they're neutralized, then you'll have the volume of the known solution. And so then you can use your molarity to try to figure out what the unknown concentration is. So basically, I have it set here. I'll explain in a moment. So that's what titration is. So basically, you're reacting an unknown concentration, a substance of an unknown concentration, with a substance with a known concentration, and then you're using that to try to figure out what the unknown concentration is, or the concentration of your unknown is. So when you get to the point at which you've neutralized, that would be considered the equivalence point. So at the equivalence point where you've completely neutralized acid and base, so we're talking about acid and base titration, but titration can be used for a lot of different substances, as long as that they react with each other, and you're able to have the concentration of one thing, and you're looking for the concentration of an unknown substance, or the unknown concentration of a known substance. So when you reach what is called the equivalence point, where you've completely neutralized, or you've completely reacted one substance with the other, so that in an acid-base titration, that's where you're going to reach neutralization, where there's no more acid and base. And so that point is going to be when the number of moles of, say, for example, if you're adding OH minus, then the number of moles of OH minus that you've added, or the amount of base, the moles of base you've added, is equal to the moles of, say, the hydrogen or the acid that you were neutralizing. Okay, so let me go through the titration and then kind of put this together using the examples that I have here. So let's say my known concentration, so my known is NaOH. So I'm going to have like a standardized solution of NaOH that I know the concentration of, and but I don't know I'm using this burette here. So a burette is an apparatus where it holds the liquid, and it allows you to add a certain amount of the substance in the burette to, say, an Erlenmeyer flask with another substance. So this is really good. The burette is really good for measuring precise amounts of volume. So you're going to use, typically, this is the titration apparatus you're going to be using. So you have a burette, and the burette is going to be filled with your the substance that you know the concentration of. So in this case, let's say I have a known concentration of NaOH. So I'm going to fill my burette with NaOH, and I'm going to know the concentration of this. And then in my Erlenmeyer flask, I'm going to have, say, my acid here. So this is my unknown concentration of my acid. So this is what I'm trying to find. So I don't know the concentration of my acid, but I do know the volume. So this is measured out precisely. So I've measured out the volume of my acid, but I don't know the concentration of it. So, so what I'm going to do is, since I know the concentration of the base, and right now I'm representing the base as OH, because that's what's reacting between this strong base and strong acid. The OH and the H are reacting to form water. So the other stuff I don't care about. That's just going to be a salt that's dissolved in water, and that's not going to affect the experiment. So in this case, I'm just representing the base as OH minus and the H as H plus, because that's where the reaction is, and so that's what's going. That's what I'm comparing in my calculations or in my experiment. So the OH is going to be added. So I start at a certain volume and I measure that volume because that's important. That's a starting volume. And what I'm going to do is I'm going to add my OH minus, my base. I'm going to keep adding that to the hydrogen, and as I'm adding it, the H plus, the protons are going to be neutralized. They're going to react and form water. And then I'm going to keep adding the OH until all of the protons, or the H plus, the acid, is neutralized. And the way I'm going to know that is we add an indicator that's going to change color based on whether it's in acid or in a basic solution, right? So here, the popular indicator is phenolphthalein, and phenolphthalein is going to be clear in an acid. So you can see that it's clear here. But when you go into a base, when the phenolphthalein is in a basic solution, it's going to turn pink, right? So when I'm adding my base, so here's where the volume of my basic solution here, my NaOH solution. So when I'm starting, I'm going to start to add NaOH. So here's the NaOH. I'm starting to add, and let's indicate here. So it was up here, and now I'm adding my NaOH. And the OH is now reacting with the H plus down here. And so as I'm adding this and as the OH is reacting, it's forming water, and you can see that there are less H pluses in here than in here. So I am neutralizing the acid, and so the H pluses are going down. And when you get close, when you start to get really close to the end point, or where you have neutralization, complete neutralization of your acid, you'll start to see a pink. You start to see it turn pink as you drop in there, and this should be swirling. So you're either swirling it by hand, or you have a magnetic that's being mechanically turned by another magnet, called a stir bar and a stirrer. But you're stirring this, and when you start to get close to what is called the end point, and the end point is where the point at which the color change occurs during the titration. And again, that color change occurs because the indicator that you put in there, you just put in a few drops. The indicator phenolphthalein is going to be clear in an acid, but as you're neutralizing the acid and getting closer to the end point, the base, as you drop it in there, is going to turn pink, and then if it's swirling, it'll like disappear. And that's when you want to slow down your titration. And there, maybe one drop at a time. Drop, swirl it, and then if it turns pink and then disappears right away, then you add another drop. And what you're doing is you're adding drop by drop, and you're swirling, and you're seeing how long the pink color changes or stays. And you're looking for a very, very, very light pink color, right? Not really pink. So, and this is where if you're really good at it, you can add half drops or partial drops to your Erlenmeyer flask. And so I've seen really good ones that the only way you could see the color change is if you compare your flask here with another flask that hasn't been titrated yet. So that way you can kind of compare them and see if there's a light color change. Or if you stick a white blank piece of paper behind here and compare it to the white, you can see if there's a slight pink color. And that's when you've reached the end point. And I try to write this here, but it's pretty pink or red down here, so that's the best I can do. So here you're close, but the pink, it goes away. So if the pink goes away, you got to keep going. And then you get to the point where the pink color stays for at least 15 to 20 seconds. you're swirling, you're looking at it, and if it's still there after about 15, 20 seconds, you've reached the end point, and you stop adding there. And then at that point, you can measure the volume that you stopped. So if I began up here before I added my NaOH, and I added all the way down to here, and I stopped here because it turned a light pink color, then this is the amount of the NaOH that I added. So now I have a very precise measurement of the volume of my known NaOH, my known base. So I know the concentration, and at the end I know the volume that I added to neutralize my acid. So now that my acid is neutralized, there's nothing in here but water. So now what I can do is I can take my known molarity, right, which is the concentration. So that's molarity, right? And if I know that molarity is moles over volume in liters, then what I can do is I can use the volume, right, in liters, and I can then multiply, right, if I multiply both sides by volume, then volume times the concentration in molarity, volume in liters times concentration in molarity, will give me the number of moles of my base that I added. Well, if the number of moles of my base, meaning the OH, and specifically the OH, the moles of OH that I added, then that number of moles of OH is going to equal the moles of H plus that were originally in my solution. And then I can figure out from there, if I know the moles of H plus and I know the volume, then I can go back to my molarity equation again, because molarity is equal moles over volume in liters, right? So if I know the volume in here, all I need to do is make sure it's in liters. And then since I calculated the moles of OH, and that's equal to the moles of H plus that were originally in there, then I can figure out the moles of H plus that were originally in my solution, right? And then there I can figure out the concentration of my acid, okay? One of the things I want to point out really quick though is if you have a 1-to-1 ratio here, like for every one of these I have one OH or one hydroxide, and for every one of these I have one hydrogen, then everything works out in a 1-to-1 ratio. So the concentration of H plus that I find should be the same as the concentration of the acid, right? If it's a 1-to-1 ratio. But what if you have a diprotic acid or a polyprotic acid, right? So then my H plus, right, if I have H2SO4, right, if that's the acid that I'm titrating, then my H plus, my moles of H plus is going to be double the moles of the original acid. So the molarity of H plus is going to be, it's not going to be the same as the molarity of the acid itself, right? So then I'm going to have to half the molarity, the number of moles, and things like that. So I have to take that in consideration when I'm trying to figure out the moles of my acid. Or also, if you're using a base that is, like let's say magnesium hydroxide that has 2 OHs there, right? So then the concentration of my MgOH2 is not going to be the same as the concentration of the OH minus, because I have 2 OH minuses for each MgOH2. So you got to be careful of that when you're doing these sorts of calculations. But that's pretty much what a titration is. I hope this is helpful, and if you like this video, please share the video, like the video, subscribe to the channel, and make a comment in the comment section. Let me know what you think and any questions you have, and hit the notification bell if you want to get notifications for any other videos that I'm going to put out. Thank you for joining me, and I'll see you next time.